Okay, welcome back to this next lesson in this advanced trigonometry section. Today we're going to look at using the sine rule to find an angle in a triangle. Okay, the motivation for this is simple. It's that standard trigonometry, remember the old SOHCAHTOA, is amazing, but it only works at right angle triangles. So if someone asked you to find angle theta in this triangle, you would struggle because it's non-right angled, so you can't use standard trigonometry. But the inverted version of the sine rule will save us. Inverted just means upside down. Okay, so you can actually turn the sine rule from last lesson. Remember the sine rule from last lesson was A over sine A equals B over sine B equals C over sine C. You can turn it upside down to get this version here with the angles on top of the fraction, which is much easier to work with. So you want to find an angle with a sine rule, then just use the inverted version, turn it upside down. I used to remember the normal version, this one, and then remember in the exam I could turn it upside down. Okay, let's do an example then. So pause the video, draw this picture, and then come back to me when you're ready to look at the solution, okay? Okay, welcome back. So I want to find angle theta and then angle delta. All right, so angle theta first, look, okay? Because I want to find angle theta, I'm going to call this angle A. So this will be side A. All right, so remember then, if I want to use the sine rule, I need another matching pair of sides and angles to work with. So I can see that these two, B and side B, match. I couldn't use C because there's no value for side C, okay? So the version of the sine rule I'm going to use is sine A over A equals sine B over B. Put your values in. So I don't know what A is. Uppercase A, that is. Lowercase a is 13. Sine B would be sine 64. Put it in brackets, I think, to help the calculator. And B is 12. Now I've got to get A on its own. So I'm going to get rid of this 13 first of all by multiplying by it, like we did last lesson. And that's going to leave you with sine A is going to be, don't work this out on the calculator, okay? It's going to be really messy. Just do this, leave the fraction and multiply it by 13. All right, if I wouldn't even bother doing that on the calculator just yet, save it, okay? Because this sign has still got to go. If you want to get rid of a sign, then you need to take the inverse sign. So you can, on the calculator, you can type all this in one line. It's brilliant, this is, okay? It's the inverse sign of sine 64 over 12 times 13. You could actually work out this thing here if you wanted to. Push equals, then do the inverse sign of the answer. But I think this way is a bit neater. So put this on the calculator. So shift then sine, brackets open. Sine 64, close bracket, go down, type 12 times 13. And you're going to get that A is 76.83 degrees to 2dp. Remember, A was actually called theta. So I found theta. All right, so I'm going to get rid of the unknown and put the value on the picture. Remember, always put it on the picture. Now, to find delta, then it's easy because I know two angles in a triangle. So to find the third one, I add these both up. I'll show you a little shortcut here as well, okay? You remember, you add up what you've got and take it off 180 degrees. So actually, you could do this on the calculator to speed things up. 180, take away the sum of the other two angles. So 180 take away 64 plus 76.83. Remember, the brackets are essential here, okay? And you get the delta is 39.17 degrees. Okay, if you prefer to do 64, add 76.83 first, push equals, then take off 180, then feel free. But this is my speedy way of doing it, my efficient way of doing it. Okay, example 2, pause it, write it down, and then come back to me when you're ready. Okay, welcome back. I got to find angle theta again, so I will do this, A and A. And again, the only other matching pair I can use is 78 and 20. Okay, so again, I'm going to use the inverted sine rule. Sine A over A equals sine B over B. And this means then that sine A over 10 is sine 78 over 20, as before. Multiply by 10 first of all. So you get sine 78. Let me put it in brackets again so the calculator doesn't sulk about it. Times by 10. And then take the inverse sine. So A is the inverse sine of sine 78 over 20 times 10. So put it in the calculator again. So shift sine fraction sine 78 close bracket over 20 times 10 gives me 29.28 degrees to 2dp. And remember, this was angle theta. So angle theta is now known, which is 29.28 degrees. If you want to find this here, this letter here is Greek letter phi or phi. I call it phi. So phi, I'll do 180, take off the sum of the other two interior angles. So 180 take away 78 plus 29.28 gives me 72.72. That's a nice symmetrical number, degrees. And with that, we're done. Okay, so for the main task now, it's 4 to do. In each case, find theta first, and then find the other missing angle. Okay, so have a go, and then come back to us when you're ready. Welcome back. I put the answers on this slide. Theta first, then the other letter second. If you want to learn some Greek letters today, this one here is called gamma. This one here is called psi. The x is called chi. And this u with an extra tail on it is called mu. So make sure you mark what you've done while I do a quick time check. Pretty good to go. And here comes the checking question now, okay? So pause the video, write this down, and then I'll see you shortly for the solution on a blank slide. Okay, welcome back. What you've noticed here, I suppose, in it is that, as always, there's no picture. So I will draw a picture first, and then worry about the perimeter of the triangle, okay? So let me draw PR first of all, badly, as always. 30, remember the comma stands for inches, okay? This is 13.21 inches. RQ is 3.27. So I'm assuming it goes this way. If not, though, it won't really matter. As long as the numbers are right, we'll be good to go, okay? RQ is 3.27 inches. And then it says then the angle Q to P to R is 14.3 degrees. Okay. Find the perimeter of the triangle. Remember, perimeter means you have to add up all the sides. Okay. At the moment, I only know 2 of the sides. So I got to find this side for a start. So I was hoping I could use the sine rule here. If I label these sides, look, Q, P, and R, I can't use the sine rule just yet because, to find this length, because I can't do R over sine R. All right, I don't know it, which is a slight problem. Okay, and I can't even find angle R yet because there's no matching pair. So I just do what I can. I notice that I've got a matching pair here. I got one side with this angle here. So I think I'll try and find, I could find angle Q first, couldn't I? All right, I will use sine Q over Q is sine P over P and put my numbers in. Okay, let me do my little separator just in case it gets a bit messy. All right, so sine Q over 13.21 is sine 14.3 over 3.27. I'll take a little shortcut now, okay? All right, hopefully you understand this. If you see it in 2 steps to find angle Q, remember I would do sine 14.3 over 3.27 times 13.21. But remember, I would also need to take the inverse sine. Remember, take the inverse sine of this here. I'll do it in one line to speed things up, okay? Hopefully that makes sense. See, times by the 13.21 first, and then take the inverse sine. So the inverse sine of fraction sine 14.3 close bracket over 3.27 times by 13.21 gives me angle Q is 86.21 degrees to 2dp. Okay, so I'll put that on the picture. I'll try and do it in blue. I'll probably mess this up though. So angle Q is 86.21 degrees. And while I'm at it, I may as well work out angle R as well. Okay, because I got 2 angles, and why not go for the third? I might have to use it. So maybe that would be 180 take away 14.3 plus 86.21. Okay, so 180 take away 14.3 plus 86.21. Angle R is 79.49 degrees. So I'll put that on the picture as well. And now I win, because now I've got R. I can do this from the previous lesson. I can do R over sine R. You can pick any one you want to, okay? Because I've got Q and I've got P. Matching pairs. I can use the matching pair of P though, okay? Because this was given to me in the question, and so is this. So they're bound to be right. So I will use P over sine P. Remember, okay, I'm using the normal version of the sine rule here, so I want to find the length. I want the length on top. So R over sine 79.49. So I should have put brackets there, sorry. Okay, and then P is 3.27 over sine 14.3. And from a previous lesson, just multiply by sine 79.49. So R is going to be 3.27 over sine 14.3 multiplied by sine 79.49. So fraction 3.27 over sine 14.3 multiplied by sine 79.49 gives me that R is 13.02 inches to 2dp. So I'll put it on the picture. R is 13.02 inches. Remember, you asked to find the perimeter. So to find the perimeter, just add up all the sides. 13.21 plus 3.27 plus 13.02. So 13.21 plus 3.27 plus 13.02 gives me that the perimeter is, oh, lovely, 29.5 inches. Okay, and with that, we're done. So thanks for listening and watching. Stay safe and see you soon.